Hi, everyone. Sorry, I accidentally had to end the meeting. So can you all see the whiteboard now?
Yes.
Oh, good. Okay, let's start with the first problem. What answers did you all get? Good, I see quite a few answers of 21. Let's see, Ahana, can you explain how you got 21?
Okay. So I had to find the least common multiple of 12, 14, and 15, which was 420. Then I did 420 divided by 20, which was 21.
Good, yep. So in this case, it happens that the LCM of 12, 14, and 15 is also a multiple of 20, although we would want to make sure that it also was a multiple of 20, and we might actually have to take LCM with 20 as well, but good. So the kind of key point here is that we know that all of them need a whole number of cents to buy. Each piece of candy is always a whole number of cents. So whatever the total amount that Casper has, that's enough to buy 12, 14, or 15 pieces of these different candies. So 12 of, let's say the red candies are, so 12R is equal to 14G is equal to 15B, where G is the cost of a green candy, B is the cost of a blue candy, or N times 20. So we know that these are all equal and they're all integers. So we want some number for this that's a multiple of all of 12, 14, 15, and 20. So the 20 doesn't actually matter because 5 is a factor of 15 and 4 is a factor of 12. So it happens to be that just the LCM of 12, 14, and 15 is enough. And like Ahana said, this is 420. And so if this is all equal to 420, then the smallest possible value of n is just 420 divided by 20, which is equal to 21. So one extension to this, what is the next smallest possible value of n?
Is it 42?
Good, yep. So if you take the LCM, the next multiple of this LCM would be 840. And then 42 would be the next n. Good. But yeah, any multiple of 420 here would be that works for the total, and then you could compute any of the cost of each candy based on that. Any questions on this? Okay, let's move on to the second question. Okay, good. 5 is correct. Let's see. Vedant, can you explain?
Yeah, so I found out the number of green marbles. No, I mean the number of total marbles in each jar, and I got 450. And then I did, and then I found the number of blue marbles by multiplying it by 9 and 8, and I got 5 more in jar 1.
Okay, good. How did you get 450 total?
So I did x over 10 plus x over 9, which was 19x over 90, which I put set equal to 95. And then I got 19x equals 8,550. Then I got x equals 450
Good.
for the marbles.
So yep, x is equal to 450. Okay, good. So yeah, the easiest way here is just, so we'll say x is the number of marbles in one jar. And then the ratio of blue to green marbles in the first jar is 9:1. That means that 1/10 of them are green marbles in the first jar. And the second one is 8:1 ratio. So 1/9 of the marbles in the second jar have to be green marbles. So, you know, if x is the number in each jar, x over 10 is the green marbles in the first jar, x over 9 is the green marbles in the second jar. The sum of the two is 19x over 90. That should be equal to 95 green marbles in total. So then you can get x equals 450 being the total number of marbles in one jar. Now the final question is, how many more blue marbles are there in jar 1 than in jar 2? So for that, we just need to compute the blue marbles. So in the first case, it's 9x over 10. So in this case, that would just be 405. And in the other one, it would be 8x over 9. So that would be 450 divided by 9 is 50 times 8 is 400. So the difference between 405 and 400 gives us the 5 marbles. So this is one way of doing it algebraically. So you take a variable of x. Any ideas of any other ways of doing this problem?
So so we know that the ratio is 9:1 and 8:1. So if you add up all of them, you get 19. 9 plus 1 plus 8 plus 1. And 95 divided by 19 is 5. We know that the first jar, the ratio is 9. The second jar, the ratio is 8. And so there's a 1 difference. So the difference would just be 5. Or you could do 5 times 9 is 45 minus 40 is equal to 5.
Good. Yeah. So I think the ratios method is good. So one thing to be careful is that when you take 9 plus 1 and 8 plus 1, you want these kind of ratios to equal the same amount, since you know kind of there's the same amount in each one. So I think it's a little bit, or you can do this by making sure that the sum of these 9 and 1 and 8 and 1 in the ratios become the same. So in this case, this sums to 10 and this sums to 9, right? So what can I multiply each of these ratios such that they have the same sum?
You would have to do times 9 to the top and times 10 to the bottom to make it 90.
Good. Yep. So the first ratio then becomes 81 to 9. So that would sum to 90. And what would the second ratio be?
80 to 10.
Good.
Which would also sum to 90.
Good. So now I have the ratio. So I know in the first jar, so it's the same ratio, right? 9 to 1. I just multiplied it by a larger number such that now these two these two are now equivalent in sum, right? So both sum to 90. Now we can go back and see, okay, there are 95 green marbles in total, right? So this is, both of these ratios are blue to green marble ratios, right? So if I actually just had 81 and 9 in the first jar and 80 and 10 in the second jar, I would have a total of 180 marbles, right? And of those 180 marbles, 19 would be green, right? 9 green in the first and 10 green in the second, so 19. So then this next step is the same as what you said. So then there are 95 green marbles divided by now the 19 green marbles I'm seeing here. So that's a multiplier of 5, right? So I basically just need to multiply these two ratios by 5 and I'll get the true values. So 81 to 9, if I multiply this by 5, the first jar has 405 blue and 45 green, and the second one has 400 blue to 50 green. So this is a way of just doing it in terms of ratios. You don't even need to use any variables. You can just think about it in terms of ratios. Any questions on this? Okay, let's move on to the last question. Okay, good. 1 over 80 is correct. Okay, Pavan, can you explain?
Okay, so it's asking that so one guy has to pick a number, and the next guy has to be a multiple of that number, and the last guy has to have a multiple of the second number. So since it's 1 to 10, it's not going to be that many cases because there's only 10 options, and after like 2, if it goes like 1, 2, and 4, it's not going to go high. So we can just count each case. So counting the cases, we're starting off with the first guy having 1. We can have 1, 2, 4. And we can have like 1, 2, 6, 1, 2, 8, 10, 2, 1. And then we can also have, we move on to like 9, 3, 1. And then 6, 3, 1. Now we move on to the 2, so we do 8, 4, 2. I think we can do 8, 4, 6. Oh no, that doesn't work, never mind. Then we can do 8, 4, 1. And then 10, 5, 1. I think that's it.
Makes sense, yep.
And then so it's 9, and then we divide it by 10 times 9 times 8, since there's 10 options for the first number, 9 for the second, and 8 for the third. 9s cancel, so it's 1 over 10 times 8.
Good, yep. So why is the denominator 10 times 9 times 8?
Since we have 10 options for the first number, and then 9 for the second, and 8 for the third.
Good, yep. Good. So yeah, I think in this case, the easiest way is to actually count the possibilities where, so in this case, we're asked that Al's number needs to be a whole number multiple of Bill's, and Bill's needs to be a whole number multiple of Cal's. So you basically need Cal's to, imagine this to be a small number, so Bill's has to be a multiple of that, and Al's has to be a multiple of that, and no two of them get the same number. So you can't actually have the same number. Otherwise, it might have been valid to say like 2 of them have the same number, so that's also excluded. So this means the easiest is when Cal is 1. So then Bill could be 2, Al could be 4. Then if Cal is 1, Bill is 2, then Al could be 6, 3 times that, or 4 times that, or 5 times that. And these are the 5 cases up to that. Now after that, you can't do 6 times that because that would be 1 to 12. And we only are going from numbers 1 to 10 inclusive. So then you can look at, again, 1, 3. You could do 1, 3, 6, 1, 3, 9. Again, if you try to do 3 times 4, 12, that won't work. And then 1, 4, 8 we have, and then 1, 5, 10. 1, 6 will again not work because 12 goes above 10. 2, 4, 8 will work. But nothing above that. 2, 4, 12 again will go out of 1 to 10. So there's actually a pretty small number of possibilities that work. Here there's only 9 possibilities that work. And then counting the total number, here it's Al has 10 choices for any of the numbers 1 to 10. Bill has 9 choices for everything except the one given to Al. And Cal has 8 choices except the ones given from Al and Bill, so 8 choices there. And one thing to note here, so this is permutations and not combinations in the denominator, because Al, Bill, and Cal, it matters the order of the 3 numbers you pick. And you want to pick like the first number for Al, second to Bill, and third for Cal. But think about in this sets, this you have a particular order because we know Al's number is a multiple of Bill's and Bill's was a whole number multiple of Cal's. If we actually didn't put this restriction, we could have allowed if we just said that one of them is a multiple of another and the third is a multiple of any of them, then we could actually consider any permutation of these. So 2, 4, 1, 2, 1, 4, and so on. For this one, in this case, since we have this order specified here, we only have these exact possibilities. And the denominator, we consider order 10 choices for Al, 9 choices for Bill, and 8 choices for Cal. Does that make sense? Any questions on this? Okay, then that's it for today's class. We'll see you all next week.
Thank you.
Thank you. Bye.
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 Thank you.